Hello everyone, welcome to our midterm project of AI and cybersecurity. The title of our project is Cloud-based PE malware detection API. And so in this lab project, what we are going to do is we are going to classify PE files, which are portable executable files, whether they are malware or they are not malware, that is, they are benign files. So we are going to utilize malconv deep neural network, which will be based on Pytorch, and we are going to make use of technologies such as Google Colab, AWS SageMaker, Streamlit for mainly three tasks. So our Google Colab would be used for training. So we would make use of high-end free GPUs in Google Colab for training our Pytorch deep learning neural network, and we'll save that architecture and we will deploy that model in AWS SageMaker as an endpoint to check uh, for all other PE files, whether they are malware or not. And for doing that, we'll use a client in Streamlit and we will pass in files to check whether they are malware or not. And for training, so before going into that, let's see what is PE files. So PE files or portable executable files are executable files in Windows operating system. For example, I can give you like calc.exe, vlc.exe, explorer.exe. These all exe files are portable executable files, and they contain different characteristics such as architecture, entry point, section layout, and um, they can help us in understanding if a given file, executable file, is a malware or benign file. And for that purpose, we are gonna use this malconv architecture. And you can see the 32-bit file structure for a PE file. Here we have many features and data that can be taken out of it. And now going into malconv, it is a deep learning model designed to detect malicious Windows portable executable files. It makes use of CNNs to analyze raw byte level content, and it can help us to recognize complex patterns within the PE files. Uh, yeah. So this is the malconv architecture. This is the input layer where we put in our binary files, or more specifically, the featureized vector for our binary files. And we do an embedding, and that is passed into 1D convolution network. And there is sigma and multiplication layer. After that, we do max pooling, and it is passed into a fully connected, I would say, deep neural network based on our architecture. And we have two outputs. Since it's a classification of binary classification, we might have either malware or not malware, like malign or benign. So we have softmax activation function to get those probabilities. And we are using Pytorch library mainly for this. And Pytorch is a open source machine learning library, and it allows us to train the model in with the help of GPUs. So we have make use of Gold Colab GPUs because we have huge training data and our model is quite complex and large. So we would require high-end resources to train our data. Without GPU, it will take a very long time to uh, train our model. And this is the architecture of the PyTorch. You can see there are data source batch tensor. We train in batch and we save our model currently for in our local folder so that we can later on deploy in S3 and AWS SageMaker. And talking about AWS SageMaker is a service provided by AWS. It is used for building, training, deploying many kind of things, but we are mainly using AWS SageMaker in this project for deploying our model as an endpoint. And you can see here, since it's in the cloud, it can be scalable. So we can use different kinds of machine as per our needs, as per our use cases. Let's say we are to uh, check for thousands of PA files, we might make our model instance a bit large. If not, we can make our instance a bit small. And so yeah, or as already stated, this project dealt with three steps, I would say. One is building and training the model, other is deploying the model as a cloud API, and third, creating a client application. And we made use of Ember 2018 V2 dataset for training our model. Mm, Okay, deployment was made with the help of AWS Academy free account, and we made sure that we don't cross the $100 credit limit. And yeah, malware line, project results, evaluation. As seen in the graph, we can see our training and validation accuracy, training and validation loss decreased over the epoch so that we have not overfitted the model. And we can see our accuracy was around 0.82 with our precision 0.78 and 0.877 recall. It seems pretty good. Seeing at the confusion matrix, you can see we have a very high false positive rate. So many of our benign false are treated as malware. And yeah, that is not good in that aspect, but still, you can see other data seems pretty good. And this is a screenshot of our client. I will talk about, we'll see in the demo later. And yes, we have successfully concluded our project. We have done all the three steps. And what were the some of the shortcomings or hurdle and future work that could be done? So some of the shortcomings were, yeah, so, since the data was very large, even the Google Colab free resources could not handle that much. So we used to do, we tried doing sampling and we tried uh, training in batches. So yeah, and another hurdle was this the libraries for Ember dataset that we used were not very uh, up to date. It was there were some broken dependencies and all, so we have to take care of this individually, and it took a lot of time to figure out which works and which does not. And yeah, and also deploying the model in AWS SageMaker has a learning curve, so it takes time to learn all of those. And yeah, it was fun learning all of those. And for future work, what we can use is advanced deep learning architecture. We used the basic malconv architecture, and we trained our model, so we can use more advanced deep learning architecture, high-end resources. So we made use of Google Colab free GPU, but we can use uh, more better GPUs so that we can train much better and on more data. Transfer learning, we have not used transfer learning, we could use that. Even though the dataset was diverse enough for our resources, but yeah, given high-end resources, we can use more diverse data. And these are some of the resources that I have used to make the project uh, complete. And so now let's go to our code. This is our streamlit app. So this is our client, and this is our endpoint. And just go through it just this much, and let's go to our deployment. So the deployment is in Colab. So, so you can see this is our Pytorch endpoint that we have deployed, and it's in the notebook Midterm. If you go through it, okay, we can go through it later. I'll just start it for now. And what we can see, this is our repository, GitHub repo. So we have deployed all our files. This is our PT file, and there are pickle and weights. So I have used min-max scaler in the model. So when using test or deploy uploading our PE files, I need to extract the features. So I have used min-max scaler, and I need those for normalizing the feature vectors. So yeah, this is also required. And let's check it out. So going in the code, let's run our deployment. Okay, it seems our deployment was running. So I'm running this our client, and the client is available in F501. So going here, localhost F501, and it says that we can drag and drop files here. So there are two payloads, one is benign and one is malign. Let's say, check it. So these are, let's classify it. And the classification, benign is, the output is, it's a benign software. For malign, it's a malware. So this is our result on this. And this is our endpoint. And Let's see if we can see. Okay, even if we can't see here, I will show that locally. Mm, so in the code, this is our deployment code. So here, what we have done is, so we have installed some of the libraries that we need. After that, we installed our Ember, Leaf, and Light GBM, what we require. We import our libraries, and then we get our AWS credentials and roles here. This is the bucket and role, and we tar our file. So model one is our tar file. So we make a tar file from our model, and we put that in our bucket. And so this is our, so we have an inference.py file, and we use, okay, inside the code folder, we have our inference.py file. So in here, we have our model architecture. We have a model function that takes the path. We have our input function that takes the input and returns the data. We have predict function. We have an output function. So if prediction is greater than 0.5, it's a malware. If not, it's a benign software. That's the output in JSON format that is given to our client. And we were in our deployment. And so this is inference, it's in the code. And yeah, so we are using MLG4DNX large instance for our deployment. And this is our deployment code. So yeah, we deploy here, classify and deploy. And so, and let's go to see here. Okay, yeah, now we can see our Jupyter Lab once more since we have done that. Start, and you can see here this malconv to GPU. This is the same code that we use in AWS SageMaker to deploy our code deployment. And we have inference.py here. We have our model here, model.r.tz. So yeah, this is all for our midterm. I think this is all we have now. Thanks for listening.